All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for this event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use the question and answer tab there on your interface and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. We also have a very interactive chat feature, so I do encourage you to chat us your questions, comments, suggestions, whatever you want to share with us. Go ahead and use that chat tab and get it on in, and we will keep an eye on that chat and maybe even chat you back. And then finally, at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, let's kick off today's webinar, which is Scaling Kubernetes with Splunk and AWS. Our speakers today are Amit Sharma, who is the Director of Product Marketing at Splunk, and Ranjit Kalidasan, who is a Senior Solution Architect over at AWS. Gentlemen, thank you so much for joining me today. Really do appreciate it. Amit,
Right.
I think you're going to be kicking us off today, Amit. So I'm going to go ahead and take myself off camera, put myself on mute, and let you dive right into it.
All right. Thank you, Charlene. Thanks so much. And welcome, everybody. Welcome again. And thanks for joining us today. My name is Amit Sharma, and I'm delighted to have Ranjit from AWS joining us today. So today we'll be talking about scaling Kubernetes, specifically with AWS, EKS. And we are going to take a look at different deployments, different performance anomalies that you might encounter every day in production as you start your journey or you continue on your journey of Kubernetes. So just a bit of introduction about myself. So as I said, I do product marketing at Splunk. Before Splunk, I was part of SignalFX team. And SignalFX was a real-time cloud monitoring company that Splunk acquired almost 2 years to date. Before SignalFX, I was part of AppDynamics. So I've been in this monitoring and observability space for quite some time now, but majority of my career has been as a software engineer. So I've been in your shoes for majority of my career. Ranjit, do you want to say a couple of words about yourself and your role?
Thanks, Amit. Hello, everyone. My name is Ranjit Kalidasan. I'm a senior solutions architect working for AWS. So I work in a role called Partner Solutions Architect for North America ISV Partners team. So in my role, I support partners like Splunk for various activities like product integration activities with our AWS services and features, and working with Splunk for various go-to-market and go-to-sales activities. I'm very glad to be here to co-present this event along with Amit.
Very good, Ranjit. Thank you again. So everybody, so we will start by looking at why customers are adopting containers. What are some of the challenges, operational challenges with monitoring and operating distributed systems like Kubernetes? We will take a look at why EKS. So there are over 260 plus Kubernetes implementation in CNCF. CNCF certified Kubernetes implementations. Why specifically EKS? And then what we'll do is we'll take a look at live demo and we will simulate some real-time, we'll show how to monitor and troubleshoot performance anomalies with Splunk infrastructure monitoring and Splunk Cloud. And we will have ample time towards the end for question and answers. So let's get started. So first, why customers are adopting containers. Again, the first point of reducing risk is interesting, but less intuitive. After all, VMs provide complete isolation. However, Kubernetes also offers a rich set of controls that can be used to effectively secure clusters and their applications. Kubernetes network policies, for example, behave like firewall rules that control how pods communicate with each other and other endpoints. Operational efficiency. So Kubernetes is self-healing in nature. It continuously reconciles what is the desired state of a system and what is the current state. And it takes corrective actions if need be. For example, if a pod or a node dies, then Kubernetes will try to restart the pod, or auto scaling policy in AWS will start the node. Going further, bin packing basically deploys multiple containerized workloads on a node, which will increase your infrastructure utilization and hence uh, your better cost optimization. Portability and standardization lead to lower time to provision services and deliver new features. Automation increases the speed and ease of testing and iterating. So if Kubernetes provides all these benefits, why is every single workload not on Kubernetes today? Well, there are challenges. There are challenges in operationalizing Kubernetes. Now, here we are looking at CNCF survey, and they found that complexity and monitoring are some of the top challenges, top inhibitors for companies to adopt Kubernetes. And monitoring becomes even more difficult as the scale of the company increases. Let's talk about scalability challenges. Now, as we know that Kubernetes is a distributed system, you can see from the graphic, a creation of a single pod may need creating multiple objects, 50, 60 objects sometimes. And these are just internal Kubernetes objects. Then you have backend services. Then you have microservices deployed on top of Kubernetes. Frequency of deployment, especially when you are using immutable infrastructure. That is, you make a build, you release, you deploy from scratch, and this will churn the entire infrastructure stack, and maybe churning thousands or tens of thousands of containers every time you push a release. Adding fuel to this fire is cardinality. You are adding dimensions to metrics so that you can get insights about your system, easily slice and dice data. Things like properties, labels, tags. These dimensions result in high cardinality, which slows down monitoring systems. You want accurate alerting too. You want to evaluate composite metrics, not just one single raw metric. You want composite metrics, and you want to apply some statistical functions on those metrics so that you get patterns and trends, not just the raw metric up or down. All these reasons make traditional monitoring systems unsuitable for cloud-native environments such as Kubernetes, especially at scale. We'll talk about how Splunk solved these challenges in a bit, but first let's talk about AWS. AWS is a company which knows a thing or two about scale. So I was reading this, that AWS is 65% of organizations are running their containerized workloads on AWS. So let me pass it on to Ranjit. And Ranjit, why don't you tell us more about EKS and why EKS is a great implementation of Kubernetes?
Sure, thanks, Amit. As Amit stated, right, why containers, anything related with containers important to us is because of the previous slide we have seen, right? About 65% of container workloads on public cloud is running on AWS. So that is why any containers related services like Elastic Container Service or Elastic Kubernetes Service, ECS or EKS, is very important to us. So before we talk about Kubernetes or EKS service, let's spend some time on why we build a service like EKS service, right? The reason why we built a service like EKS because managing a production scale Kubernetes clusters could be very challenging for customers. Oftentimes, the customers require a dedicated and a skilled workforce to go and maintain the clusters, manage the operational lifecycle of the cluster component softwares, manage the upgrades, and so on and so forth, right? And also they have to ensure that any workload running on the containers are not exposed to any security vulnerabilities. So this add additional complexity in managing those clusters, right? So oftentimes customers want their IT resources to be spending on the time which is what is important to the business rather than managing and maintaining the underlying heavy lifting of the infrastructure, right? So that is why customers have relied with AWS to build a service that could scale, and so that we can manage the underlying infrastructure for them, and so that they can operate the Kubernetes service clusters in a scale. The next slide, let's look at some of the few important characteristics of EKS service, right? These are some of the important characteristics of EKS service. First and foremost, EKS is a fully conform to the open source Kubernetes version, right? EKS is a complete upstream certified and conformant to the Kubernetes version. So we even backport the security fixes to provide that consistency to our customers. So currently EKS supports about 6 versions of Kubernetes. I believe it supports from version 1.16 to version 1.21. So this gives customers the ability to manage their roll out the upgrades between the versions. And also we backport the fixes, the security patches and fixes across these versions to provide a consistent experience to the customers. We even support that versions that are not supported by the open source community. So overall, we want to provide the managed experience of the Kubernetes service to be fully performant, right, and provide a managed service to our customers that can scale, that can be stable, that can be reliable, and also operate to provide the overall experience, and so that customers have a very less time to actually manage the Kubernetes clusters rather than focus on the business. In the next slide, we'll see some of the architectural components of the EKS. When customers deploy an EKS cluster in AWS, they're apparently going to get 2 different endpoints, right? For someone who is managing the cluster or administrating of the cluster, they have an EKS regional endpoint. An EKS is a regional service, which means that you get a unique endpoint by region. So cluster administrators go and invoke API commands to build the clusters, create the clusters, manage the node groups, and all the things that are required to manage the infrastructure of the cluster. They use that endpoint. And the developers often use the API server endpoint, very default endpoint that comes with the Kubernetes, any Kubernetes clusters, to roll out their upgrades, to deploy their services and applications, right? And from an end user perspective, they get the endpoint that has been deployed within the containers of the applications. Usually, if a service is deployed as a load balancer, it will be the DNS name of the load balancer that the business, the end customers will operate, or any other way the application has been deployed. In next slide, we'll see a further drill down into these components. So with EKS, all the control plane components of the EKS is managed by AWS. So we provide a single tenant deployment, which means that each tenant belongs to one customer or one EKS cluster. So all the master node components for an EKS cluster, like your HCD server, your scheduler manager, your control manager, or API server endpoints, right, or API server, all of that gets deployed across 3 AZs in our region. So we deploy across 3 AZs so that we provide the resiliency and high availability of the control plane components. From a customer, customer has the ability to deploy the node groups or the nodes as part of their data plane across their VPCs, right? And they have a different customer deployment options they can choose on type of the instances they can choose. They can choose to run it on the on-demand instances or the spot instances to save some cost. Or the other option, which is not provided in the slide, is to use a Fargate profile. Fargate is a serverless deployment option where we manage the underlying infrastructure, and customers can define a Fargate profile, and we will manage and scale up and scale down based on the demand by the applications. So in our next slide, we'll look at some of the recent announcements we made in the space. While EKS is the best place to run the Kubernetes workload on public cloud, there are times that customers have asked us to get this experience or deploy this in their hardware that they own in their on-premise data center. There are various reasons why customers were asking for it. Part of that could be they want to have the portability across different environments. They want to have the Kubernetes cluster running very close to their business for data sovereignty requirements and many other reasons, right? For those customer requirements, we recently made two announcements. One is a EKS distro. With EKS distro, the open source version of EKS, basically the EKS version that we run on cloud, we made it open source. We're providing to the customers, right? So it is a complete version that is powering the EKS. It's the same exact level of major, minor, and patch level that is available for customers to deploy it on their on-premise infrastructure. The announcement we made is EKS Anywhere. EKS Anywhere again is powered by the same EKS distribution or EKS distro software or package. But then along with that EKS distro, we provide some additional management tools. And it's basically an opinionated software or opinionated stack that we built for customers. So this helps customers to deploy EKS on their infrastructure and to give a control plane experience with their AWS console. And there are different modes that customer could operate. A fully connected mode where they have the control plane access from AWS console, or partially connected mode, or a fully disconnected mode where they can run the EKS Anywhere in the EKS distro in their infrastructure. And from a support perspective, EKS distro will leverage the community support because we have open sourced it, and we will try to maintain the patches and fixes on a best effort basis. But EKS Anywhere, customers can have the AWS to support the EKS Anywhere feature or service by the customers. So they have to go and subscribe the support option from AWS, and we can support the stack. So in the next slide, we'll look at the integration of EKS with other services. As many of you know that AWS has 200 plus services and features, and EKS comes with a deep integration with some of those services. So from a networking point of view, all the networking components that get deployed as part of the EKS stack are the AWS resources. For example, if you deploy a service like a load balancer type, in the backend, you get an application or a network load balancer getting deployed in a VPC. Similar way, we configure the DNS entries using Route 53 and configure Amazon VPC, other networking components like security groups or NACLs for customers. From a storage perspective, EKS integrated with Amazon Elastic Block Store, Amazon Elastic File Store, AFS, and FSX. FSX is the network file store for high performance computing or Windows-based servers. So this will provide a persistent storage option for the Kubernetes workloads. From a security perspective, we have integration with Amazon KMS or Key Management Service to encrypt the data and object within the containers. And for any role-based access controls, this integration with Amazon or AWS Identity and Access Management Service. We also have an integration with the AWS Web Application Firewall to manage and control the ingress traffic to the EKS containers. And from a compute perspective, customers have different deployment options they can choose. They can choose and pick the right size EC2 instance for their workloads. And this could be across different EC2 instance family. Customers can also deploy on high-end machine learning or GPU-based instances. Or other option is, as I mentioned earlier, customers can go for an AWS Fargate option where they simply create the profile and we will handle all the underlying infrastructure deployment for the customers. So in the next slide, this slide just gives a view of some of the compliance framework that the EKS currently supports. Customers would belong to a different industry segments, and each industry segments will have a very unique compliance needs. So customers can inherit these controls and build on top of what is currently offered in EKS rather than beginning from the scratch, right? So this is an advantage customer get. In the final slide, I'll just give the summarized view of the various deployment options that EKS provides to the customers. So from a purely customer managed options, customers can use EKS distribution or EKS Anywhere, so they can deploy EKS on their hardware that they manage. They could also use AWS Outpost where both the hardware and the stack will be managed and supported by AWS. The other option is customers can also deploy EKs in the local zones. Local zones is an extension of the availability zones that customers can avail from, apart from the regions we support, to the cities that some of the known cities across the world. And finally, EKs in AWS is the highly performance EKS clusters that customers can deploy in AWS regions. So with that, just conclude my session, and let's hear from Amit what Splunk has to offer to monitor and manage EKS.
Yeah, thank you, Ranjit. Appreciate it. So let's take a look why monitoring in Kubernetes is challenging. Well, first off, there are just more number of components. You have the physical box, then you may have hypervisor, you may have guest operating system, VMs, and then you might be running Kubernetes and container runtime. If you're running on Amazon, then there's VMs and then EC2 instances, for example, container runtime like Containerd or Docker, Kubernetes platform, and then you have monitoring microservices deployed on that. So this is just more number of components with multiple multidimensionality at scale that leads to slower visualization. So your traditional tool used to monitor just the virtual machine or bare metal server based deployments. Now we have just so many more components. Then we have ephemeral or dynamic environments like containers, right? Container can come up or go away within seconds. We have multiple data sources. We have metrics, traces, logs. So SRE teams, cloud operations teams, which are looking at maintaining and monitoring Kubernetes clusters, they are continuously switching between these data sources, data types in different tools. That leads to this context switching leads to higher mean time to resolution, higher mean time to detect. And finally, all this data is coming into the monitoring system at such a great velocity, great speed. Correlation of different events that are happening across different components manually is just not feasible. So traditional tools which do not use data science, machine learning, they will struggle to correlate and generate insights from all that data coming into the system, will struggle. And so what is needed for observability in Kubernetes? Let me just build this slide up. So first of all, we need to be able to understand the health of Kubernetes cluster and all the resources, entirety of the Kubernetes environment. Then we need visibility into individual components. So as we talked about, there are so many components, right? We have nodes, we have pods, we have containers, container runtime, Kubernetes objects, we have our microservices deployed. We have backend services like a storage or network interfaces that we need to monitor. So visibility into all those components. While monitoring will give us up or down where there is some problem, right? If there is a problem in our stack, we need to pivot to logs to troubleshoot and find root cause analysis. And that pivot has to be seamless and it should be contextual. Otherwise, you're looking at something wrong in the monitoring screen, and then you're going to logs and trying to find out where is the problem, when did the problem happen, which component is having the problem. So all that context from your monitoring system should be carried over to your logs seamlessly so that you can immediately start root causing and troubleshooting the performance issues. And finally, these systems, they change so often and at a great speed. So you need streaming analytics and accurate alerting. And we need some data science and AI-driven automation so that we can make sense of all this data automatically. And don't just take our word for it. So we have this Gartner report, and I'm going to read this quote or this sentence from that report. Favor tools that have granular logging, supply automated service discovery, and can provide action-oriented recommendation in real time using analytics and or machine learning. And by the way, you have the access to this entire report, the full report. There is a link to this report in the handouts on your screen, so you can download the entirety of this report. So Gartner is saying the same thing, and this is what we have built. So I want to talk to you about Kubernetes Navigator. Kubernetes Navigator is not a product; it's a feature within Splunk Infrastructure Monitor. It provides the visibility into the entirety of your Kubernetes environments, multiple clusters across multiple availability zones or regions on EKS or other Kubernetes implementation. So we're going to talk a little bit about these features very quickly, but I want to show you these features in action in the demo. So let's talk about fully automated Kubernetes monitoring. It's a one-step, zero configuration installation, Helm-based installation. And by the way, there is an issue here. The screenshot is not coming up, but not to worry, because we will see these actions in these things in action in our demo. It can automatically discover Kubernetes components and deploy the applications. So things like you're deploying on top of your Kubernetes environments like Nginx, Cassandra, MongoDB, Redis, all these integrations. We have about 200 of such integrations. It will discover automatically. It will then, once it discovers, it will provide you a pre-built curated dashboard for immediate value. So you get visibility into the entire stack, not just your EC2 instances or Kubernetes platform or container runtime, but also your services that you have deployed from one single solution. Starting with the bird's eye view, Kubernetes Navigator enables teams to quickly understand the performance of the entirety of Kubernetes environment with intuitive hierarchical navigation. You can select, filter, search for any Kubernetes entity, that is node, pod, container level, within seconds. While a global at-a-glance view into the entire Kubernetes environments help team understand the overall system, how overall system is performing, it is equally important to have a granular, detailed view into individual components. So you can narrow down to the source of problem, drilling down from nodes to pods to containers to workloads. Streaming architectures enable in-depth analysis with search and filter grouping within seconds at a massive scale. We talked about this, right? So seamlessly pivot to logs and get granular visibility into application Kubernetes container logs to correlate performance across the entire stack without any context switching. Visibility into lifecycle events of Kubernetes and API server or control plane help you understand and maintain your security and compliance posture. And finally, on this feature set is the automation piece. It's that data science, leveraging data science to understand the why behind performance anomalies. It uses data science, which automatically surfaces insights and recommendations to precisely answer what is causing anomalies across the entire Kubernetes cluster. So we are going to look at these features, but let me speak about EKS Anywhere and EKS Distro. So EKS Anywhere is your self-managed on-premises environments. And EKSD is, by the way, EKS Anywhere, you will get consistent tooling such as EKS CTL support, EKS console support from Amazon, while EKSD is your DIY Kubernetes implementation, which is used by managed EKS service as well. So you can run EKS Anywhere, and you can use a Splunk to monitor and troubleshoot any Kubernetes-based performance anomalies, no matter where you run Kubernetes, either managed or hybrid using EKS or AWS Outposts, or EKSD on your on-premises environments. If you are running EKSD or EKS Anywhere, you are also responsible for monitoring the control plane, internals of Kubernetes, right? Things like API server, etcd, scheduler, controller manager. So Splunk Infrastructure Monitoring provides out-of-the-box monitoring for your data plane, right? All the services that you're running on your data plane, as well as your control plane. So all these components that you see, API server, etcd, scheduler, controller manager, as well as on the data plane, kubelet, Kubernetes service proxy, container runtime like Docker or Containerd, network and storage interfaces, as well as the add-ons that you have deployed like Kubernetes DNS server. All these visibility and monitoring is provided out of the box for you. I want to talk to you about, I'll spend a few minutes. Whoa. Sorry about that. Spend a few minutes on our streaming architecture. So traditional batch metrics, batch and query architecture is based on querying. So time series metric data is put into a time series database. And traditional tools will have separate systems for alerting, analytics, visualization, automation, and data science. Now, that you are seeing on your right-hand side. All these systems will periodically pull the data from TSDB and update their state. So that could be 1 minute, that could be more than that. Now, this approach was primarily used in pre-container-based era, right? It used to work fine for virtual machines and where number of components were less. But as the data has exploded and has become more dynamic and ephemeral, this batch and query approach does not work. So I want to talk to you about our streaming architecture and how we build it. So we do not periodically pull a TSDB. We stream data as it is coming into our system to the components that you see on the right. So it provides a uniform platform with analytics, alerting, automation, data science in real time. Let's take a look at this in a little bit of detail. So first, why we are choosing streaming analytics for metrics? Because monitoring ultimately is not just putting a pretty chart on wall TV. Monitoring is putting yourself in a position to anticipate problems. Monitoring should really be about interactive visualization, using data to explore, query, and understand your system. It should be about zero-lag alerting. Because your end customers, they are expecting a flawless experience. So you should be able to respond within seconds. So now let's take a look at how we do it. And the way to read this slide is from left to right. First, we separate out the metadata from the data value right at the front door. And metadata is, again, availability zone, region, application name, dev, QA production, all these tags and dimensions that you're putting on your metrics. So we separate out from the metric data value. And we do that so that it allows us to scale these two systems independently. Second, we dynamically adjust the jitter or lag in your metric data value. So sometimes there is a network latency, and if you're expecting metric data to come in at 10 seconds resolution, and the next value does not come at 10 seconds, traditional tools, they act like deer in the headlight. We handle that jitter automatically. And third, we put all the data in data stores, persistent data stores, but we optimize it for retrieval time so that historical data can be used in analytics with the real-time data. And fourth, we are streaming the data that is coming in to the components that they need the data. So your charts will refresh, your dashboards will refresh, your automation tasks will trigger, your alerts will fire within seconds as the data enters into our system. So now we will switch to a demo. In the demo, we will talk about creating an EKS cluster using different choices that we have, managed node groups or unmanaged node groups or Fargate, and what are the different considerations in these two aspects or these three aspects. We will simulate some performance anomalies, and then we will use Splunk infrastructure monitoring and Splunk cloud to monitor and troubleshoot those real-world performance issues. So let me switch to my demo environment. So I want to show you, before we get into Kubernetes, EKS deployments, I want to show you, give a little bit of introduction to Splunk infrastructure monitoring. And what you're looking at is Splunk infrastructure or Splunk observability cloud, and we are interested in the infrastructure, which gives instant visibility into your cloud footprint, like a cloud stack, as well as like Kubernetes or Amazon services that we are showing here, as well as over 200 integrations. And let me give you an example or a real quick flavor of the real-time streaming architecture. So this is our demo environment. We have deployed thousands of EC2 hosts running different services. You could see at a glance a bird eye view of how the fleet of EC2 instances providing is working. So, but what you could do is you can quickly search or group or filter by any label or tag or property that you have assigned to your dimension. So here I say availability zone, and all that within seconds, less than a second, it is able to filter down there. And then you have performance characteristics of the entire fleet. You can quickly drill down into an individual server or individual service and get performance characteristics of those services. So here, moving on to real quick on EKS cluster. So here I have deployed EKS cluster or 2-node EKS cluster, and I want to talk to you about different options that are available to you. So I have deployed an EKS cluster named EKS cluster in the US West 2 region. There are many options, multiple options. One is managed node groups. Managed node groups is EKS will, or Amazon will manage the life cycle of EC2 clusters. So EKS has given the APIs, or they have developed APIs to manage the life cycle. So I have deployed one instance as a managed node group. On the unmanaged node groups or node groups, we have one instance, and then you have also the flexibility to use spot instances. You can deploy your workloads which are not sensitive to keeping the state as spot instances. You can use a combination of on-demand instance and spot instances. So here I'm saying, hey, I want maximum size of 1. This is my maximum price, 3 cents per hour. And you can find out from EC2 pricing what is the spot instance price on your region and what type of instance you are running, a T3 large. And I want these many spot instances. You can have a distribution of on-demand and a spot instance. In this case, I'm running an on-demand instance here and a spot instance here. What EKS will do is it will deploy in different availability zones, these two instances. And we were talking about, Ranjit was talking about Fargate profile. So I created a Fargate profile of FP And what I'm telling that if I create a Kubernetes namespace dev, then any workload that is deployed in dev namespace should be run as a Fargate EKS. Now, there are some pricing considerations that you should be aware of. Here you are looking at EC2 pricing. In the Fargate, you are no longer responsible for managing and maintaining infrastructure or paying for infrastructure. You're just paying for your workloads that are running in Fargate. So this is what I have deployed. And let's take a look at Splunk infrastructure monitoring and how we can, it gives me the bird's eye view of the EKS cluster that I have deployed. I have 2-node EKS cluster deployed here. In our demo environment, we have multiple Kubernetes clusters. So this is our dynamic cluster map, which gives you the entirety of Kubernetes environment, multiple clusters, sometimes 2 clusters, sometimes hundreds of clusters, tens of clusters that you have across different teams, different applications, or different stages of applications. So coming back here, let's take a look at how, so this particular, this is my cluster. This is a node level view. I can click on the node and get the details on that particular node, how that node is performed, performance characteristics on that. I can get a detailed view of that particular node. So I could see what containers are running on which node and how much performance or how much resources are being spent by a particular container or particular workload. Now, I wanted to show you this because we saw the at a glance view, and now we can see how quickly you can drill down to individual component into your Kubernetes environment. So going back to this particular node, just by visually looking at the node, we can see here everything is working fine, right? This is my node. This particular square is a pod, and this little container is the rectangle is the container. So visually, I am looking at hierarchical navigation. I could see my node is working fine. Most of the pods are working fine, just visually looking at this running. But there seemed to be some issue with this particular pod. And by the way, I have an e-commerce application, microservices based application deployed on this pod. So I could see there is something wrong, right? Because it is telling me it is red details on the pod. This is something to be investigated. So I could click on this and I could go from monitoring workflow point of view. I could say, hey, I want to examine what's going on with this pod, this workload in Splunk. So when I go to Splunk, you would notice that I don't have to write any SPL. All that context, the pod and the workload that I was looking at, all that context has carried over to Splunk. So let's take a look at what happened. So just by looking at this log message, it says back off restarting failed container right here. So I can quickly see what was going on. It is getting into crash loop back off. And that happens when there is an issue with the workload. As soon as with the application, as soon as the application is starting, looks like there's something wrong with the application and the container is crashing. So let's take a look at the workload. So I have deployed these different workloads on my cluster. So let's click on that email service, which was having issues. And again, we want to go and check out in Splunk. So detail on workload email service, examine in Splunk. So as you saw, when we pivot from monitoring to troubleshooting, it is seamless workflow, and it is carrying the context of the monitoring of the object that we were trying to monitor, email service workload there. So let's take a look at and see what is our application log say. So it says that there is an issue in the application, email server.py, line 54. This particular assignment is causing the Python runtime to crash. So every time when this particular line is executing, it is causing Python to crash. So as SREs, as cloud operations teams, we can take a quick screenshot of this, or we can share this with our developers and see, hey, there's something wrong with your code, and take a look, which is causing the containers to get into crash loop back off status. I want to show you one more thing. I have deployed a cron job here. I'm calling it hungry cron job. So what I did, I wanted to see what happens if if the application requests more resources than what is available on your Kubernetes cluster. So here in this cron job, I have requested 50 core and 32 gigs of memory. 50 core of CPU and 32 gigs of memory. And I know that in my small 2-node cluster that I created on EKS, we don't have that many requests. So Kubernetes should not be able to schedule this pod. Now, if an application developer has sent you or they have deployed this application in production, you may not know because this will not even show up, right? Kubernetes will not deploy this pod. How do you go about finding this and troubleshooting it? So we can go again to our Kubernetes cluster, Splunk Infrastructure Monitoring, Kubernetes Navigator. It is looking at the entirety of the cluster. And we are going to take a look at what we call Kubernetes Analyzer we were talking about earlier. It is looking at the cluster and it's finding out performance anomalies automatically. So you don't have to create proactively see what is going on in your environment. It is looking at the entirety of the cluster and surfacing the insights that it finds on why the performance anomalies would be caused. So in this case, I'm looking at hungry job. There's something from, right? It says related to pods with pending status, and it has tried to schedule this pod 255 times. So it is trying to schedule, but it is not able to schedule. So if you were to troubleshoot this, so you can just say you can just look at Splunk and find out why it is not able to schedule this pod. So we are looking at the contextual logging of this, and here I can see the logs from my cluster. 0 of 2 nodes are available, insufficient CPU, insufficient memory. So within like few clicks, we saw that we were able to find the root cause of a performance issues. And then we can get the code level insights on where exactly the program or the application is failing. And that helps us triaging and troubleshooting. It automatically gives us a guided, a prescriptive way to start triaging. So it told me that, hey, there's something wrong with this hungry workload or cron job that you have deployed. Start triaging there, start troubleshooting there. So let's go back to slides. So all these features and capabilities that we have built, what do they deliver for our customers? What outcomes? So of course, productive IT teams and happier end users. One such example is reduction of toil, and one such example of that is this customer of ours. They were able to reduce toil or manual work in creating and maintaining alerts across different technologies that they have deployed in their stack by 90%, because the entire platform is available as APIs and signal flow, which is our programming language to access uh, the functions and libraries for our platform. Faster mean time to detect. So I did a side-by-side comparison. So using Splunk infrastructure monitoring, you could detect a performance issue or an event that is happening on your in your cluster 80% faster than other competitive solutions that are available in the market today. We give complete visibility into how much monitoring resources are you consuming, like how many metrics are being used. So you have centralized visibility and control on how much monitoring different teams um, across your company are consuming, and you can control that using tokens and quotas. So it's much more efficient usage of your monitoring. And finally, one customer of ours found that teams which are using Splunk infrastructure monitorings, they are about 8 times more productive, in a sense that they are delivering new features to production 8 times faster. And that is because they are confident that a Splunk infrastructure monitoring, our metrics-based platform, will be able to identify any anomaly that they might introduce because of new release, and they can take automated action. So it improves your developer productivity. So with that, we are coming to an end. If you have not yet tried Splunk infrastructure monitoring, please go ahead and sign up for free trial. It's fully functional free trial, bit.ly/infra-mon. Um, and it's not only easy to get started with one stack Helm-based installation, but also it's easier to scale your operations as you mature in your Kubernetes journey. So let's take questions if you have.
Yeah, so we have gotten a couple questions in, so we'll go ahead and take those. There's time though, guys. If you have a question, please go ahead and use the question and answer tab and submit your question. If we don't get to your question during the Q&A session, please know that the folks at Splunk are going to get a copy of all the questions that came in, and I'm sure they'll be more than happy to follow up with you after the webinar. Okay, here's a great question for you. Why would we choose EKS Anywhere or EKSD over managed EKS? What are their cost implications?
Yeah, Ranjit, do you want to take that?
Sure, Amit. Yeah, that's a good question. So EKS, as I explained earlier, EKS-D is EKS distribution, is an open source version of the software that powers the Amazon EKS. So customers can use it. As it is an open source version, they can use it and deploy it on their infrastructure running on their on-prem, all the components involved to build a Kubernetes cluster, including your data plane and control plane, everything. The same goes with the EKS Anywhere, except that with EKS Anywhere, you get additional tooling, and it comes with like I said, it's an opinionated stack, which means that it comes with all the pre-configurations enabled to help customers to deploy a robust cluster, reducing the complexities, right? And from a support perspective, EKS distro uses a community support, and EKS Anywhere customers can go and subscribe for the support, and that's also the response for the pricing. Only the support cost is involved with EKS Anywhere, and EKS distro is provided with no additional charge. And I can post a link for EKS Anywhere pricing for other additional information.
All right. Great. Next question here. Is Splunk infrastructure monitoring a different product from Splunk?
A good question. So Splunk infrastructure monitoring is built on SignalFX technology that we acquired 2 years ago. So it is a different product than Splunk logs, but they work together to give you monitoring and troubleshooting workflow, so that you can detect performance issues in real time and troubleshoot and root cause and triage those performance issues using a Splunk logging product, um, and reduce your MTTR.
Excellent. All right, great. Next question, can OpenTelemetry monitor workloads deployed on Kubernetes?
Yeah, great question. And I didn't cover this in the talk. So basically, what happens is how we do the Helm-based installation. This is OpenTelemetry based collector, which is getting all the performance data from your nodes and pods. It runs as a daemon set. It can not only gets performance insights for your infrastructure component like node, pod, container, and workloads, Kubernetes control plane, but also the applications or services that you have deployed on your cluster. So I mentioned this, that we have over 200 integrations for technologies that you use every day, right? Things like Nginx or Cassandra, MongoDB, Redis, Kafka. If you're running any of these technologies, then it can get performance characteristics from these integrations, automatically discover and provide you with the pre-built curated visualization so that you can get instant visibility into the entire stack of technologies that you're using.
All right, great. We are about 6 minutes to the top of the hour, so I think we have time for one more question here, maybe two, we'll see. Let's see. Okay, we currently use Splunk for log collection and searching. is there an additional cost for the infrastructure monitoring?
Yeah, so we talked about this in the previous question. There is a separate product. There is a separate license that you need to get. This can be licensed on a host-based model. So it depends on how many nodes that you're running within your cluster. You can get uh, Splunk infrastructure monitoring for those many hosts that you're running on your Kubernetes cluster. Yes, it's a separate product, and you need a separate license.
Okay. All right, great. Let's slip one more question in, then we'll call it a day. Let's see. While looking at the cluster map, and more specifically at a single node map, are those red warnings on container level customizable on some metrics? As far as I understand, they give us some hints about a failed pod or container, or a pod or container that continues to reboot. Nothing else?
So it is looking at the life cycle of the Kubernetes objects that it understands, right? So all the objects, nodes, pods, containers, workloads, and the interdependency of those. It can give you warnings on those conditions. Separately, it is the warning that we saw is all automatic. It is looking at the entirety of the cluster and any performance anomalies or patterns it detects. It will give you a warning on that. Separately, you can set alerts. So what you are referring to here, it can set alerts based on any condition that you are, or any metric that you are monitoring. For example, container restarts. So if you have a workload and there are multiple restarts that are happening, which are anomalous, right? So we have sophisticated alerting algorithms like sudden change. So it can automatically discover that, hey, there's a sudden change in the restarts for this workloads. So that can automatically trigger an alert, and you will get notified. You could use those alerting algorithms to basically alert you on any metric of your choice. One such example would be our customers using it. I was talking to the customer just last week about this. So they are monitoring Kubernetes control plane, and they have an alert on the number of Go routines in Kubernetes control plane. So if that increases and there's some change, they know that there's something, either traffic's increased a lot and there are a lot of chatter, a lot of API service calls, or API server calls, or there is something performance anomalies has happened, systematic issue. So the short answer is you can create alerts on any of the metric that you have, either about the infrastructure or about the application or about business metric that you are monitoring.
All right, great. Well, we are about 3 minutes to the top of the hour. So unfortunately, that is all the time that we have for questions. But as I said before, if we didn't get to your question, I know there are at least one or two that we didn't get to. Please know that the folks at Splunk are getting a copy of all the questions that came in, and I'm sure they'll be more than happy to follow up with you offline and get your question answered. Another quick reminder that today's event has been recorded. So if you missed any or all of the presentation, or if you just want to watch it again, you'll have the opportunity to do so. Following the webinar today, we are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, before we close out the webinar, let's go ahead and do the drawing for the 4 $25 Amazon gift cards. Our first winner today is Jean G. Congratulations, Jean. Our second winner today is Sujith K. Congratulations, Sujith. Our third winner today is Isaac T. Congratulations, Isaac. And our fourth winner today is Kelly K. Congratulations, Kelly. We'll be following up with all four of you via email to get your Amazon gift card over to you. So please check your inbox. And if you don't see anything there, please check your spam folder. Rajit and Amit, thank you both for a great presentation. What good stuff! I really enjoyed it. I'm a big fan of demos, so I especially love that. But thank you both for coming on the webinar today and sharing your expertise with us. Really do appreciate it.
Thank you.
Yeah. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.